Welcome back, everyone. The next theorem about the medians in a triangle concerns the centroid of a triangle, which is the intersection of medians. Now, the centroid of a triangle divides each median into two segments whose lengths are in a ratio 2:1, with the longest one near the vertex, meaning that AG will be the longer one and it will be twice as long as GD. So in other words, in this triangle we can say that the ratio AG to GD equals 2:1. Similarly, the ratio BG to GE will also be 2:1. And last but not least, the ratio CG to GF will also be 2:1. So they make actually three parts when you think about it. So another way of saying this is AG will be 2/3 of AD, the whole median. Okay? And GD can be 1/3. Now, let's take a look at some numbers because numbers kind of make it easier for us to understand how this theorem works. So suppose that AD is 12 centimeters. If AD is 12 centimeters, that means AG will be 2/3 of it and GD will be 1/3 of it. So 2/3 and 1/3. So in other words, AG will be 2/3 of 12, which is 8, and GD will be 1/3 of 12, which makes it 4. Similar to this, if we had, for example, BE given 15 centimeters, then we'll say that BG will be 2/3 of 15, GE will be 1/3 of 15. So that means this will be 10 and G 5. And let's do the last one. We'll give CF 27 centimeters. So we'll say that if CF is 27 centimeters, that means that CG will be 2/3 and GF will be 1/3 of 27. So CG will be 9 times 2, which is 18, and FG will be 9 times 1, which is 9. Now, on this grid below, I thought that would be a good idea that we draw a triangle, not just one. You can draw as many as you wish, and draw the three medians in a triangle, and use a ruler to verify whether the two segments created in each median stand at the ratio of 2:1. So practically what I would do is just draw any ordinary triangle, draw the three medians in the triangle, and use a ruler to measure the ratio of the line segments that are created by the intersection of the three medians. If you want to verify it, you want to use probably more than one triangle. Now, we're going to go over a couple of examples to practice the two theorems that we just learned. Example number 1 states that the area of the triangle XYZ given here is 18 centimeters squared. So XYZ is 18 centimeters squared. The median XW, that's the median XW, is joining the vertex X to the midpoint of YZ, which is a W. We have to find the area of the triangle XYW. So in other words, we need to find the area of XYW. So this triangle here. Now, remember that the theorem about medians that concerns the area states that the area of the triangle created by the median will be 1/2 of the area of the bigger triangle. So, I'm going to say that the area of triangle XYW must equal 1/2 the area of the triangle XYZ. Why is that? That's theorem 1 about medians. Two triangles of same area. Now, you're probably wondering right now, do you have to do this all the time when you're solving a problem? You can write the theorems for short, so you don't have to write explicit explanations, but again, we're going through examples together, and that's the reason why I'm being a little bit wordy. So that would equal 1/2 then of XYZ is 18 centimeters squared. So from where we get that the area of XYW equals 9 centimeters squared. Now, the next question asked is to find the area of the triangle XWZ. Now remember that XWZ is the area created in the triangle from the median XW, right, in the bigger triangle here. And remember again that based on theorem 1, medians will create two triangles of the same area, or each triangle will have an area twice as half the size of the area of the bigger one. So we're going to write that area of the triangle XWZ must equal the area of YXW. Again, it's because theorem 1 states that median divides the triangle into two equal areas, right? So therefore, we're going to say that the area of triangle XWZ equals 9 centimeters squared as well. And now we're going to move on to a more interesting problem. Example number 2. In example number 2, we are given a triangle, as you see here, ABD. You probably see that this angle looks like a 90-degree angle. Please do not make any assumptions unless you see a small little square in here, or unless you're given that this is 90 degrees angle, right? A 90-degree angle. So in this triangle, we have AC given as 3x plus 7. So this is AC, is 3x plus 7. And CG is 2x minus 1. So CG is 2x minus 1. And C is the centroid of the triangle. I'm sorry, I'm going to add this. That was given in the problem. Since C is the centroid of the triangle, it means that these two sides will equal each other, these two segments would equal each other, and these two segments here would equal each other. So we are going to say then that the ratio AC over CG must equal 2 to 1. Why? That is the theorem number 2 about medians. Intersect at centroid, which divides into segments at a ratio 2 to 1. So now I'm going to substitute AC, 3x plus 7, and CG, 2x minus 1. And I will try to solve the equation. So remember, you can do cross multiplication here very easily because we have a single fraction in each side. And that will give us 3x plus 7 equals 2 times 2x minus 1. So we ended up with a linear equation in this case. 3x plus 7 equals 4x minus 2. 3x minus 4x, negative 2 minus 7. Negative x equals negative 9, which makes x equal to 9. And that's what we were asked to find here. I will extend a little bit this problem actually to finding the actual lengths of AC and CG since we have the value of x. So if x equals 9, that means that AC would equal 3x plus 7 or 3 times 9 plus 7. So 27 plus 7, 34 units. And let me write this a bit more nicely. Units. So AC is 34 units, whereas CG, which is 2x minus 1, is 2 times 9 minus 1, or CG equals 17 units.